In this tutorial, we will build an online first contact screen using SwiftData. You'll see real records in the list in a minute, and we'll begin to design the model and also sync to Firebase later. So this is the app at the moment. I'll now show you Firebase. You can see there's no records there. So now I will create a few records. That's the first record. But I will disconnect the Wi-Fi so that the data isn't pushed to Firebase. I now save the record to SwiftData. I'll create another record. And save again. And you can see that the records have not been persisted, they haven't been sent to Firebase because we're not online at the moment. So now what I will do, I will stop the simulator and then rerun it. And then now I will attempt to push the records to Firebase, the two records, which are at the moment stored offline. So I just pull to refresh. Oh, I've forgotten to turn the Wi-Fi on, but that's a good test anyway, so you can see that it really works. I pull to refresh it again. But there's something wrong with the Wi-Fi. Has it worked now? So let's check Firebase. And now you can see, if I click on Contacts Collection, now you can see that the two records were submitted to Firebase. My record and also Fred blogs. And we can also delete the record from SwiftData, and the records will also be deleted from Firebase. Just refresh. You can see now it just includes my record only. Today we'll be implementing more business logic within the application and not the UIs as I mentioned last week, because I forgot to implement the other functions that are needed within the application. So the first thing we need to do is to create a new file. And name the file Firestore Contact Remote Data Source. Type the following. We need to import Firebase, Firestore, and I'll just copy the code from the clipboard. So this is the code. So what we've done at the moment, this is the structure that lets us plug Firebase into the view model. And then within the initializer, the actor makes the remote operation safe when multiple task asyncs are happening at once. And the line on number 22 is a single place to define the collection name. So it makes it easier to change later. For the fetch changes since, or the fetch change since, this is the part that acts as the synchronous feature to download the changes, the records from Firebase, the changes that have been made remotely or via the application. Line 40, it decodes the file store right into our DTO. And then for the upsert function, upsert means to create and update are in one operation. And this makes sync logic more simpler to maintain. And for lines 55, we let the server side of the application update the date for us so that it is consistent through or across all the devices. Then the final line on the upset function is we merge the datasets into Firebase. And then the delete function on lines 59, we accept the record, the ID of the record that we want to delete. and the actual deletion happens on line 60. In production, you might tombstone instead of avoiding to do it this way. The next file we need to create is our SwiftData contact local data source. So that's another Swift file. Name the file SwiftData contact local data source. And I'll just copy and paste the code on the clipboard. Similar to the previous one that we just done, we have our constructor, our initializer on line 14. We inject the SwiftData container so the actor can create context on demand. And then on lines 18, SwiftData contexts are not thread safe, so we create a fresh one per call. For the fetch all function, it sorts the newest changes first, and this is great for contacts and for sync, especially like if we're debugging as well. And the if condition, if not included delete, it is a soft deleted record which stays in the DB, in the database, but don't show in the UI. Also the fetch dirty function, it really acts as a dirty queue which will include anything that's not been synced as yet. So 0 means sync, but anything else needs attention. The observe function. So there's a few issues there. We must have spelt updated incorrectly. So I'll just navigate to the contact DTO. Updated, oh, we're missing the D, so that should be updated at. Yeah, that fits the issue. On line 47, so what happened in there? What's happening? So if it exists locally, we update it, but only if the server is newer. And what else do I need to explain? Just taking a look. So this line here on line 67, if we've never seen it, or if it's never been inserted locally as sync, now that should be, if we've never seen it, then we just insert it locally as sync, and then that'll be saved within SwiftData. And for the create function, so it creates instantly and marks dirty, so sync knows it must upload. As you know, it saves locally first, or saves to local first. And for the hard delete function, so hard delete is only used after remote confirms delete to avoid data loss locally. The next file we need to create is the app container. App container. We also have to import SwiftUI and SwiftData. Contact repository, seems like there must be a typo because we created it in the previous tutorial. Contacts. Where is it now? Contact. Yeah, I spelled it incorrectly. It should be contact repository. So I missed out the O, the R, and the Y. So I'll just refactor that correctly. Yeah, its code is a bit slow. I have to do it manually. That seems okay now. So this contact repository. I'll recompile it again. Seems like I can't find it. Is it another spelling mistake? I think it's to do with the organization of the arguments. So let's just click on fix within the contact repository file. Compile it again. Still cannot find it. It must be a spelling mistake. It was a spelling mistake. Also need to import SwiftUI. Firebase. Let's just import Firestore, Firebase Firestore. Delete that one there. Compile it again. Issues with the arguments. Just click on fix. Since it seems like we must have entered the arguments in the wrong order, but clicking on fix, that should solve it. Cancel. So go back to the app container. So it seems like it's okay now. So for the app container, just like with the previous files that we worked on, we have our initializer, which is the app composition routes, and is one place where we build our dependencies as well, as you can see. And we also use app main actor because the container is used by SwiftUI and is created on the main thread. On lines 20, this is the Swift data container, and this is also our local database. We also include some basic error handling. If Swift data cannot start, the app can't function, so we fail loudly in development. On lines 25, this is the Firestore instance, which is the remote database connection to Firestore. And on line 26, this is our remote data store, which is Firebase CRUD that create read and update for the queries, which are live here. And for line 27, this is our local data source for Swift data, create, read and update, and upserts, which happens here. And on line 28, this is the repository which coordinates the local and remote, and also the UI talks only to the repository, and that's on lines 28. In next week's tutorial, we'll definitely focus on the UI. If this topic is where you keep getting stuck in SwiftUI, that's exactly what I help people with in one-to-one mentoring. There's a free clarity call link in the description.